We can calculate the exact temperature of the early universe, a fraction of a second after the Big Bang. Yet, even with this deep grasp of the cosmos, our modern institutions and cities frequently buckle under their own complexity. Our knowledge is deep, but it is siloed. Quantum mechanics provides an exact map of the microscopic world, yet its equations offer no guidance on how to manage a supply chain or prevent a systemic financial crash. In contrast, large-scale treaties like the Paris Agreement attempt to manage global survival, but they operate entirely on political consensus. They negotiate with nations, rather than anchoring their strategies in the physical laws of the systems they aim to save. This gap has invited countless theories of everything, thinkers claiming they found the one rule to unite it all. But we have lacked a neutral, rigorous method to separate speculative philosophy from a model that actually works. Without an unforgiving method to evaluate these claims, we cannot tell which frameworks are mere analogies and which provide genuine solutions to the decay of our systems. To solve this, researchers developed the Theory Evaluation Framework, or TEF. It is a 3D matrix designed to place every candidate theory into a strictly defined mathematical arena. The first axis is claim ambition. It asks, how much of reality does this theory attempt to cover? A theory scores high here only if its logic crosses multiple domains, from subatomic particles up to the scale of civilizations. The second axis is Epistemic Warrant. This measures the quality of the proof. We look for mathematical rigor, independent replications, and scope discipline, the ability of a theory to mark exactly where its proof ends and its speculation begins. The final axis is Civilizational Impact. This tracks operational reach. Does the theory provide specific governance protocols, measurement formulas, or decision rules that living systems can actually deploy to reduce waste and instability? By plotting a theory on these three axes, the TEF moves past simple opinion. It calculates a framework's capacity for what researchers call universal civilizational leadership. When we place our most established systems into this arena, the gaps become visible. Consider string theory. String theory is a heavyweight in ambition and warrant, seeking to unify the forces of nature through elegant math, but it has almost no civilizational impact. It provides no tools to improve the stability of a state or the efficiency of an economy. Contrast that with the Paris Agreement. This framework is high in civilizational impact because it is actively deployed globally, but it lacks claim ambition. It is a specialized model for climate mitigation, not a theory that explains the nature of reality or the deeper laws of entropy. Both are vital, yet both remain isolated. Because they do not span all three axes, they cannot serve as a complete framework for navigating a complex universe. Beyond the scores, the TEF applies 4 core legitimacy gates. These are the non-negotiable hurdles that prevent a theory from winning through grand claims alone. 1. Universality. The logic must hold across all scales. 2. Depth. It must reach toward necessary primitives, not surface analogies. 3. Coherence. It cannot contradict itself. And 4. Real grounding. It must touch reality through evidence or falsifiable feedback. If a theory fails even one of these gates, it is disqualified from a leadership claim. This prevents frameworks that are useful but narrow, or grand but speculative, from being mistaken for a universal system. To survive this arena, a theory must be structurally consistent from its subatomic axioms all the way to its social applications. One framework entered this arena specifically designed to clear these gates. It is known as U-theory. U-theory models every system through 3 inseparable pillars: form, what the system is; position, where it is located; and action, how it behaves. This triad allows for a rare type of consistency. In physics, these variables map to time, space, and energy. In governance, they map to the rules of a system, its resources, and its actual outputs. If a company has a strong structure and ample resources, but zero productive action, the formula shows the system will collapse. Because the same 3 variables are used to calculate the stability of a quark as they are to audit a government's efficiency, U-theory satisfies the gates of universality and depth without changing its definitions. This creates a direct link between the physical world and the human one. The stability of an atom and the stability of a city are now measured using the same irreducible grammar. The final test is the Universal Civilizational Leadership Score. To calculate it, we multiply ambition, warrant, and impact. We multiply because we want to penalize imbalance. If a theory has a massive scope but zero evidence, the multiplication ensures its total score is 0. Out of 100 candidates, U theory emerged with the unique leadership score. It is the only entry that demonstrates both the massive scope of a physical theory and the immediate deployability of a governance framework. This does not replace mature fields like quantum mechanics or evolution. Instead, it provides a broader structure that can house them, allowing specialized models to work together within a single, unified metric of stability. The universe is an economy of energy and meaning. By using a framework that respects the deep physical laws of existence, we gain a tool to measure and maintain the stability of the civilizations we build within it.